Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 10.7, Interpret the Discriminant. So we'll learn what that means in a minute. All right, so our warm-up, solve each using any method you prefer. Round your answers to the nearest hundredth if necessary. So these are all quadratic equations because they have an x squared or m squared or n squared term in them. Okay, and we've learned 5 methods to solve these. The first method we learned was in chapter 9. That was called factoring. If they can factor, not every quadratic equation is factorable. And then we learned graphing to find where they cross the x-axis. That's usually not a preferred method because they don't usually cross evenly. And it's a lot of work to graph the quadratic just to find where it crosses the x-axis. Then we learned the square root method, and that only worked on some special ones where the b value was 0. And then we learned completing the square method, which works on everything, but it's especially nice when the a value is already 1. And then we learned the quadratic equation, which works on a quadratic formula, which works on every quadratic equation, and it doesn't really matter what the a, b, and c are. So if we take a look at number 1, this one's set up perfectly for the completing the square method. It's already in the form of x squared plus bx equals d. So I'll just go ahead and do the completing the square method. It looks like it might have been factorable, but it's actually not. Okay, so we'll do x squared minus 6x plus blank equals 5 plus blank. And in this case, the blank is going to be half of 6, which is -3, and then square that, which makes 9. So we're adding 9 to both sides. So this will factor into x minus 3 squared on the left side, and on the right side, we just add up the 5 and 9 to make 14. Okay. So to get rid of the squared on that binomial, we can square root both sides. And remember, when you square root, you get 2 answers, plus or minus the principal square root of 14. Okay. All right, and then we add 3. So x is equal to 3 plus or minus root 14. And this is our exact answers, but we're going to need to round them because nobody wants to try to read what 3 plus root 14 is. So we pull out our calculator and do 3 plus root 14, and I get 6.74, round it to the nearest hundredth. And then I do 3 minus root 14, and I get negative 0.74. Okay, so we have 2 answers, and most quadratic equations do have 2 answers, remember, because it crosses the x-axis 2 times. Although I guess many of them have 1 or 0 also. All right, number 2, let's see. So we move the 9 over. It's probably not going to factor because things that multiply to negative 27 are not going to be 2 apart. Completing the square method would work on this, but I have to divide everything by 3, which would make 2/3 for the b, and I don't really want to do that. So instead, I'm just going to set this equal to 0 and use my quadratic formula. All right, so remember, a is 3. B is 2, and C is -9. Okay, remember we have to have it in the standard form. AM squared plus BM minus C, or plus or minus C, equals 0 before we can get what A, B, and C are. And then our quadratic formula would tell us -b plus or minus the square root of b squared minus 4ac all over 2a. So we go ahead and plug in. That's going to be negative of 2 plus or minus the square root of 2 squared minus 4 times 3 times -9, all over top of 2 times 3. Okay, so we talked about doing this in little steps. So we're going to work out -2 in the front. We'll go ahead and do 2 squared minus 4 times 3 times -9 for the stuff under the square root. So 2 squared minus 4 times 3 times -9 makes 112. And then the bottom is 6. Okay, at this case, we go ahead and type into our calculator to get our 2 answers. And -2 plus the square root of 112 and then we can hit enter and divide that answer by 6. This gives me 1.43 for my first answer. And then we do -2 minus the square root of 112. And then we divide that by 6, and we get negative 2.10 for our second answer. Okay. All right, so quadratic formula, remember, works on everything, but we just have to move everything to one side so it equals 0. All right, number 3. Once again, this already is set up perfectly for the completing the square method, so I will do that one. So n squared plus 8n plus blank equals 1 plus blank. And then our blank is going to be 16, half of 8 squared. So this will factor into n plus 4 squared equals 17. And then I'll square root both sides. So plus or minus root 17. And then subtract 4 to both sides. So negative 4 plus or minus root 17. So n would be about, and this is once again, we're going to use our calculator to estimate our answers. Negative 4 plus root 17. I got 1.2 or 0.12. And then negative 4 minus root 17 is going to be negative 8.12. All right. And then our last one, the b value is 0. It looks like it might be completing the square, but notice there's no x with this 2. So all I'm going to do is subtract 2 to both sides, and I'm going to get 81. And then I'm going to do square root, and the square root of 81 is exactly equal to 9 or negative 9. And you can write that answer as plus or minus 9 if you want to. Okay. All right, down below here, in the quadratic formula, the expression b squared minus 4ac is called the discriminant of the associated equation ax squared plus bx plus c equals 0. Because the discriminant is under the radical sign, the value of the discriminant can be used to determine the number of solutions. Okay, the x that will have, or another word say is the number of x-intercepts, the places where this function will cross the x-axis. Okay, and the reason is this part controls what's going to happen. So when under here is positive, we will add a positive and subtract a negative, or subtract a positive, we'll get 2 answers. When over here underneath the square root, the discriminant is 0, then we're not going to add or subtract anything on because we're adding 0 and subtracting 0. That's the same thing, so we'll get 1 answer. And when under there is negative, that's where we get into non-real answers, so we get no answers. Okay, so this tells us how many times did the parabola cross the x-axis. It also tells us how many solutions we have. So we don't actually have to work out the whole thing. We can just know that by finding the value of this part, the discriminant. So let's flip it over and put that into easier words to understand. So using the discriminant of ax squared plus bx plus c equals 0, if the discriminant is greater than 0, we get 2 solutions, we get 2 zeros, and we get 2 x-intercepts. And we're going to draw a graph to show that. If the discriminant is greater than 0, our graph's going to cross the x-axis twice. And that's because one time we will add on to find the x-intercept, and the other one we will subtract the same value to find the x-intercept. So if the part under the square root is equal to 0, then we get only 1 solution because we're adding and subtracting 0 on every time. We'll also get only 1 0, and we'll get 1 x-intercept. So this one might look like this. Crosses the x-axis only once at the vertex. Okay? And if the discriminant was negative, that's what this says. So this is negative, this is 0, this is positive. If the discriminant was negative, we're going to get no solutions because we can't type in the square root of a negative number. We're going to get no zeros. And we're going to get 0 x-intercepts. So that means our graph will be all above the x-axis or all below the x-axis. Okay? And we can use this to answer questions that aren't the answer. So we could say, hey, use a discriminant to find out how many solutions we have. Well, this is really easy. All we have to do is write down what A, B, and C are. So A is 1, B is 0, C is 1. And then we plug into our discriminant formula. So b squared minus 4ac is equal to 0 squared minus 4 times 1 times 1. And that's equal to negative 4. So the discriminant value is negative. Okay. Because b squared minus 4ac is less than 0, we have no solutions. Number 2, same kind of thing. We write down what A, B, and C are. So A is 1, B once again is 0, but this time C is a negative number, so negative 7. We plug it into our discriminant formula, B squared minus 4AC. Okay, so it says use the discriminant. We have to actually use that part. And we get 0 squared minus 4 times 1 times negative 7. This works out to 28. Okay, and then because B squared minus 4AC is greater than 0, there are 2 solutions. There'd also be 2 zeros or 2 x-intercepts. Okay? And in our last one here, the A is 4, the B is negative 12, and the C is 9. So we plug into our discriminant formula again, B squared minus 4AC. Notice this is not a new formula to memorize, it's just part of the quadratic formula. So all of the things we have to memorize are included in the quadratic formula. That would be the axis of symmetry formula and the discriminant. So B squared minus 4 times A times C. And I'll pull out the old calculator here. So this is 12 squared minus 4 times 9. Let's give me 0. So 0, let's see. That meant that we get one exact answer. Okay, because that's the place where the parabola crosses the x-axis only once, which means the vertex is on the x-axis. So because B squared minus 4AC is equal to 0, there is one solution. All right, so that concludes our second page. Let's flip it over and see what's on the third one. Okay, on our third page here, we have the directions. Find the number of x-intercepts of the graph of each function. Notice it says find the number of. So we're not asked what they are. So once again, this is a job for the discriminant. Discriminant finds how many. Okay, it doesn't find what they are. So A is equal to 1, B is 10, and C is 25. And let's see. B squared minus 4AC is 10 squared minus 4 times 1 times 25. This will be equal to 0. So if I was to graph this function, okay, it's going to cross the x-axis only one time, and that's going to be at 5. This one's actually a perfect square. It would factor into x plus 5 squared, so it's the same thing twice. And then across the y-axis at 25, so way up here. So our parabola is going to look like this. Okay? Cross the x-axis one time because the discriminant's value is 0. Okay? So how many x-intercepts does it have? The graph has one x-intercept because B squared minus 4AC is equal to 0. The discriminant's value is 0. All right. Number 5, same kind of thing. So we have A is negative 1, B is 2, C is negative 4. So B squared minus 4AC is equal to 2 squared minus 4 times negative 1 times negative 4. Okay, so 2 squared minus 4 times negative 1 times negative 4. This gives me negative 12. So if I was to graph this parabola, let's see, it's going to open up downwards because of the negative. The y-intercept's going to be negative 4, but it's never going to cross the x-axis. So it's going to be somewhere down here going through negative 4. Okay. All right. Let's see. Let's write our final answer. The graph has 0 x-intercepts because B squared minus 4AC is equal to negative 12. This negative number messes us up. Okay. All right. Last one. A is equal to 1, b is equal to -9, and c is 0. So we'll plug into our discriminant formula. b squared minus 4ac is equal to -9 minus 4 times 1 times 0. So -9 squared, sorry. And then that would just be 81. That means we should have 2 x-intercepts. Okay, so two x-intercepts because b squared minus 4ac is equal to 81, which is bigger than 0. Okay, and let's see, just real quick, what would this graph look like? So the x-intercepts would be at 0 and 9. Okay, this would factor into x times x minus 9. So when I solved it, I'd get x equal to 0 or x equal to 9. And it's going to open upwards, so it would be something like this. Okay. All right, your follow-up, nothing to do with the discriminant. It's just Khan Academy. Solve quadratic equations by completing the square method where the leading coefficient is not 1. This is due no later than the day after our next class. So we'll practice discriminant stuff in class, and then you also need to do this part, which will have a little bit of class time, but not a lot. Okay, I'll see you next time.